Assalamualaikum warahmatullahi wabarakatuh. My name is Intan Nazira binti Shamsuddin. Today I would like to present my final year project 2. So the title for my project is Image Recognition for Chili Sorting System by using Raspberry Pi and camera. So my supervisor is IR Dr. Anwar bin Muhammad Qasim. My panel 1 is Dr. Muhammad Faid bin Yahya and panel 2 is Professor Madya Dr. Muhammad Fahmi bin Miskon. The content in my slide is introduction, motivation, problem statement, objective, scope, literature review, methodology, result, conclusion, and future works. Image recognition. Image recognition is the ability of a computer-driven camera to recognize and detect objects or features in a digital picture or video. Computer vision technology that is operated by an artificial intelligence system to recognize and detect the image. Image recognition also works by detecting the silent areas, which are portions that contain the most image or object information. Image processing. Image processing is the method used to conduct certain camera operations to create an enhanced photo or to extract useful information from it. It also forms of signal processing in which the input in an image and the output may be identified or feature associated with the image production. Sorting system. So, what is the sorting system? So sorting system is to differentiate the characteristics systematically, and it also to arrange based on its group. So why we need a sorting system? So sorting system is need to increase efficiency and to improve the accuracy. So the example of the parameter that we use for sorting system is size, color, and maturity. Demotivation. So the issue that need to address is due to the inaccuracy due to manual operation, high demand in market, time consumption, high labor work, redundancy, work for pesticide spraying and grading. So we need the image processing to sort the chili. The problem statement. So the first problem statement is a system that can detect the color of chili. This is because sometimes there are some complicated system is built, but the function is not appropriate toward the system that have been built. Thus, an image recognition is developed. The second problem is the system that has high accuracy. This is because the main factor for the sorting is to differentiate the chili based on its characteristics. Accuracy is important due to get the best performance result for the chili based on its color. Therefore, the detection with high accuracy is designed by using Raspberry Pi camera and the Raspberry Pi as a microcontroller. Next, the objective. The first objective is to design the chili sorting system for quality grading by using appropriate methods such as image processing method. Second, to develop an image processing system by using Raspberry Pi and camera for chili sorting system for quality grading. Third, to analyze the performance of chili sorting system for quality grading based on image processing method. Next, the scope. The microcontroller that used is Raspberry Pi. The camera is used to capture the image of the chili. Then, the big chili is used for the experiment to undergo process image processing. The parameter that we measure is color of the chili. This is the summary of my literature review. The summarization of the article that I have been read based on its sorting parameter, device use, conveyor speed, time for sorting, accuracy, experimental use, and the advantage and disadvantage. After do the research in the literature review, I would like to conclude that my project will use the Raspberry Pi camera module V2.1 for the capture the image. The microcontroller used for the control the system is a Raspberry Pi, and the image processing method is used to determine the color of the chili. Next is the methodology. So this is my flowchart for my project. Based on the flowchart, when the coding is start, the camera capture the image of the chili. The captured image is then appear in the OpenCV in Python software. Then the image will undergo the process of pre-processing. In pre-processing, the input image, background subtraction, converting RGB to white, converting green to binary, and filtering the image. Then, the feature of the chili image is extracted and the result of the image is then processed. Thus, the value for the color will be calculated by using the algorithm in OpenCV in order to know the color of the chili. Thus, when the result is appear, the process is end. Next, the illustration of the project design, where the Raspberry Pi is connected to the monitor or PC. Next is the project progress. Figure A, B, and C shows the constructed design tools for the detection system. First of all, the detection system is constructed as in Figure A, and then the baked chili is placed under the Raspberry Pi camera. After set up the system, run the coding. The coding is run as in Figure B. Once the coding is run, the Raspberry Pi camera will capture the image of the chili, a Raspberry Pi camera which is then sent for processing by the Raspberry Pi and OpenCV libraries that use in Python programming. For Figure C, there is the lux light meter that put near to the detection area. The light intensity is carried out in this system in order to get the best detection of chili. The light intensity is measured by using the application of lux light meter that download it from the Google. There are two experiments that have been conducted to know the color of the chili. First experiment is distance of the camera from the chili, and second is range light intensity to detect the chili. For the first experiment, there are two conditions of the distance of camera from the chili, which is 16 cm and 22 cm. The detection of the chili is achieved by placing the camera based on the distance that mentioned before. The camera is placing down vertically, straight facing the chili. It is thus considered that the object's view can easily be identified as the shape of chili. When the coding is running, the camera is captured the image of chili and then processed with the Raspberry Pi controller process the image that have been taken. For the second experiment is range light intensity to detect the chili. The light intensity range that have been measured, which is in range from 0 to 200 for distance of camera between the chili, is 16 cm, and 0 to 500 for distance from camera to the chili is 22 cm. The range was chosen based on the optimum, minimum, and middle range of light intensity to detect the chili with the sharp image of chili. Before the camera captures the image of the chili, the lux meter needs to be downloaded first from the Google Play Store and place it near to the detection area. When the camera captures the image of the chili, the lux meter shows it the light intensity value. The result for the distant camera from chili of 16 cm shows the optimum light intensity that can captured by the camera is 165. So we can see that the image is sharp. So it is mean that the optimum light intensity is 165 because there is no any color at the chili. Otherwise, for the value of light intensity 45, we can see there is a color green on the red chili, where the real chili is there is not a green color. It is show the 45 if the minimum value of the light intensity. Next is the result for the distance camera from chili is 22 cm. For distance 22 cm, the light intensity is 466. So we can see that the image is very sharp and the color is same as the real color. Thus, the optimum light intensity is 466. For the light intensity value of 5, we can see there is a red color on the green chili. But for the real image, for the real chili, the green color only the green color and there is no red color. So it means there is the light intensity with value of 5 is the minimum value of light intensity. They can detect the chili. As a conclusion, Raspberry Pi camera module V2.1 is used to capture the image of the chili, which is incorporated with Raspberry Pi in order to create the image processing. The camera will capture the image of the chili and the data will send to the OpenCV in Python software to analyze it. Then, the OpenCV will determine the color of chili that is detected by compare the calculated value with the threshold value. In determine color of chili, an image processing technique is used, and all the objectives are achieved. For the future works, further investigation need to be done in order to enhance the system of vision inspection. Furthermore, to see the real sorting system, the system should construct like a production because with conveyor belt, the sorting system can be seen more clearly. So I hope someone can build the system that can be sold to the smallholders. So this is the Gantt chart for my final year project 1 and final year project 2.
This is the main setup to do the experiment. This is the image that have been captured by the camera. So the camera can detect the green color of chili and the red color of the chili. Let's say I put the green chili under the camera. So the result is the camera can detect the chili with the green color with the percentage of 100%. So when I put the red chili, so this is the image that been captured by the camera. So the percentage of the red color is 100% because there is no green color. When I put green and red color of chili, so this is the result. So for this condition, the green and red color have its own percentage. That means the camera have detect the color of red and green. In order to measure the light intensity value, so the lux meter is placed near to the detection area where the optimum of the light intensity can be measured. For the minimum value of the light intensity, the result is no color can be detected even though green or red.